Welcome to all. Today's is the concluding class of centroid. I decided to conclude today. Last few questions are there and I will tell little later about these questions. From next class onwards, I am starting the most powerful part in structure engineering, that is moment of inertia, also called as second moment of the area. That all I will discuss there. Now, question 73 now. Remember, it is exercise, no doubt. Make a note. All these are exercises. But still, this question, I will give little more information. This is the time for you, last chance for you, to understand complete concept of locating centroid. Because later, when I go to moment of inertia, at that time also location of centroid will come. I will not explain. After so much of explanation, derivation done, thoroughly concepts are explained, if someone finds difficulty, I will tell he does not deserve to study from me. Okay. So thoroughly study and not writing. Improve your knowledge, gain more concept and be firm in the concepts. See that everything is crystal clear. So now, I made an interesting question here. Today's class full 73, 74, 75 or if required one more 76. All of them are a circular lamina or a member of circular cross section. There another circular hole is made. Where hole I will tell you. Today's class circular lamina I will take of diameter, a radius 100 mm. See, this is a big circle of radius 100 mm. From there, I am making a hole or a cutout. See, hole means cutout of another circle of small diameter. This question, the radius is 20 mm, this one. See, this is a lamina, this empty portion. So, locate centroid if a circular hole of radius 20 mm. See, this radius given, be careful. Radius, actually I can mark here only, but space problem is there. Of radius 20 mm is made or cut out. You can write is made or cut out or removed, right? Whatever you want. In a circular lamina of radius 100. For this circle, radius 100. See, radius 100. So later, diameter 200. This cutout portion, radius 20. So later, diameter is 40. See, this is, I will not tell again and again in this class now. See, 100 radius, 100 radius. I am not writing 200 here. That much common sense is there. 100 radius, 100 radius. 100, 100 or 200 and 200. If you want, write somewhere. Those who want, write there. Actually not required. Understood. And for this removed part, radius is 20. So diameter is 20, 20, 20, 20 or diameter 40, 40. Where removed? See, I told is cut out or is removed as shown means, see here. If you draw, see here, light line tangentially, the left extreme edge of the hole is at 30 from center of circle and bottom extreme edge of the hole is at 25 above what? Center of the circle, big circle. Okay, this is a question. See, now make a note. See, class, we will divide into two parts. One full circle of diameter 200. This is positive. And from the 200 to get this lamina, this 2, see dark. I told dark why warning. This somebody will ask, what is warning? You are not regular to the class. I told thousands of times, what is that warning? See, that warning I told so many times. The 2 is remote area. Therefore, 1, 2. So therefore, remember, this all you write here, then write irrespective of wherever you take origin, then how you consider x and y, irrespective of that one, x bar equal to a1 x1 minus a2 x2 divided by area. This also I told you, minus y bar equal to a1 y1 minus a2 y2 divided by area, area equal to a1 minus a2. Now I will not tell. One student asked me long back, sir, instead of formula a1 x1 minus a2 x2, can we take a1 x1 plus a2 x2? I told, okay, you can take it, but do one thing, then for that removed area, you take negative. You should take, when you write a1, see, you write positive, when you write a2, negative, that will take care. He told me, yes sir, that was my idea, sir. So I am correct. He told, I am right. You are right, but you will have problem later. Because I told him, okay, for locating centroid, you can do it. You can take what removed or cut out whatever is there, a1 x1 plus a2 x2 you can take. Then for the cut out area, removed area, you use negative sign. Both are same. Then he asked me, sir, what is the problem? When you go to moment of inertia, be careful. There, your formula will become minus ig minus a square. Confusion. Full formula will be ig plus a square, but remote area, you are trying to minus ig minus a square. Or what you will do is, you will put ig plus a square, entire thing will subtract. See, suppose moment of inertia required. I for the entire lamina is I for 1 minus I for 2 will write. But if you use negative sign for area there, it will become problem. And one more thing, if you use negative sign for that one, for ig plus square, you have to use negative sign for ig also. Do you want confusion? No sir. That's why I told, do one thing, whether it is, you never use a1, see, a1 x1 minus a2 x2. Now, since you used minus sign here, there is no negative sign for area later. See, a1 is this much, a2 is this much. But remember, don't put negative here. In case you put negative here, negative will make it positive, gone case. So, a1, what in the class? I always will tell everybody, you learn the way I tell. I know the best way of teaching. Do you agree? Yes sir, we agree. Yes, then listen to me. If you got your special ideas, you apply it somewhere, and sometimes pay penalty for it, that one. Terrible penalty. I have seen sometimes people slightly deviate, they try their own tricks. Then finally they will tell, sir, some tricks you told in the class, sir, you did it. We tried it, sir, but it backfired on me. That's why, till you reach a stage where you got ultimate concept, ultimate grip, don't try anything else. Better what I tell, follow. I am the best person to give all the concept. So, therefore, see, finally, a1 x1 minus a2 x2, a1 y1 minus a2 y2, area is a1 minus a2. Now, no negative for area. Make a note. Now, one more thing is there. What about x and y? X and y sign has nothing to do with the remote area. See, that also make a note here. When you write x and y, see, that also you have to write, today only you have to write x and y, and afterwards x bar. There, if you take x right side, x bar also comes right side. If you take x left side, x bar also comes to left side from the reference axis. If you take y upward, y bar also comes upward. If you take y downward, y bar also comes downward. Then, at that time, suppose by chance, if you take the, this is your abelco, see, this abelco, extreme bottom, left extreme, see, this corner. If you take this origin, take this x this way, negative x, see, all x are positive, all y are positive. Sign is not required. Or, if you go to aterco, see, somewhere here, every x will be this side, every y will be this side. So you take that way only, no negative sign. But if you take origin somewhere else, in between, then you should be careful. Then when you mark centroid, any centroid, component centroid, if it is, suppose you take x this way, if any component centroid is as per x, you take positive, and if it is other side, take negative. Or if you take y upwards, if any centroid is upper side of the origin, you take positive. If it is below the origin, take negative. That I told better to avoid. But this question, I will take that also. I told better to avoid. So make a note, this negative, make a note now. This negative is the negative is to show that this is cutout area. Now no negative for the area. Now no negative, already taken. Now x and y, see, there sign for x and y will not depend on whether it is cutout area or existing area. Sign for x and y, that also make a note. How you consider x? If the distance is in the same direction, positive. If it is the other side, negative. See, you take x right side positive. If the distance is to right side, plus, left side minus. If that minus comes, that minus, if it comes here, that minus has nothing to do with this minus. See, when you consider x1, x2, x3, y1, y2, y3, suppose some centroids are to other side of the origin, that is which side you take x and y, if the other side, use minus sign. And remember, that minus sign has nothing to do with this minus sign. This is for cutout minus. That is, as per your x or opposite, as per your considered x or opposite direction, as per your considered y or opposite. Now I will not tell further. Okay, start. This question you are start now. 1 minute, I will pause because I have seen while editing, if the duration is more, it takes more time. So I will cut and once again start. Start now. There is one more reason. It happened some 3-4 times. I continuously recorded. But when I went and saw the camera, I am using mobile, good quality mobile. The display was not there. Then, because due to some reason, I don't know what reason, the camera stopped working. Then, what all I recorded, everything was not there. It vanished. How you will feel if I talk for 1 hour and then when I go and see there, if the recording is not done, how pathetic situation for me. So that's why I periodically pause. So that in case recording is not there, I can 10-15 minutes I can do once again. Hours together if I do. Suppose I do for non-stop 1.5 hour class. Continuously, some big problem is there. So when I go to structural or strength of material sometimes, or SFD, BMD all, a question may take more than 1 hour. But there also, I will do one thing. Periodically, I will stop and again start. Okay, now, start. What all I tell you make here. You take solution origin here, same, that is your Abelco. This time, Aterco I am not taking, Abelco. See, x, y, okay. Figure 1, figure 2. This is, see, first, centroid for entire circle here, G1. That is exactly center of the circle. Centroid for the cutout portion, G2 here. Okay, start. Part number 1, part number 2, see, once again warning here. Area of full circle, pi by 4 of 200 square, I wrote the answer. Area of the cutout portion, pi by 4 of 40 square. So area is, remember, I won't write, usually I would write here, but okay, I write here. Should not write, this area is A1 minus A2. I should not write, okay, A2. You get the area. Area in mm square, start. X1, this is 200 diameter. So 200 by 2, 100. I always use diameter. Someone will tell, sir, radius only given 100. So directly 100 you can write. You write, no problem. But I always want diameter. See, diameter 200, 200 by 2. Okay, then X1, X2. See, 200 by 2 from here to here, plus 30, plus half of 40. Half of 40 over 150. If I explain further, some will tell you are wasting time. After so much of explanation, not required. Okay, say Y. Y this way. Y1, 200 by 2, 100. Y2, 200 by 2 plus 25 plus half of 40. Okay, 145. Now you enjoy. Correctly show the calculation. See, question mark means both of them show the calculation. You write once again, x bar from OY to right side is A1 x1 minus A2 x2 divided by total area, and y bar equal to A1 y1 minus A2 y2 divided by area. Write it and get the answer. Now, therefore, centroid G will be as shown below. See here. X bar, how much you got? One thing guaranteed. See, if this circle is not cut out, centroid is here. That is guaranteed. Because you remove this area, see, this way you are losing area lengthwise. See, your centroid will shift this side. See, centroid will always shift that side, always will shift to other side. If you remove some area here, centroid will shift to other side. See, because we are losing the area. So there is more area this side. So your x bar has to come less than 100. And y bar, see, if this area is not cut out, y bar is exactly 100. Since you remove here, it will come slightly down. Yes, see, 97.917, 98.125. Therefore, from extreme left, 97.917. See, this is 100. X bar 97.917. I won't write all in millimeter, and this is y bar. See, center is here, slightly below. How much? 98.125 millimeter is centroid. Now, those who want, I won't waste time. If you want this distance, you write from 200 subtract it and write here, and from 200 subtract and write here if you want. Okay, over. Now, one small note. In this question, suppose someone will ask you, locate this, everything is over. Right here. Question is over. Question is over. Now write. Make a note. Outside make a note. Suppose somebody wants to locate centroid with respect to center of the circle. Then what to do? Then you have to tell, see, your centroid G is here. If you want, somebody wants, where is centroid with respect to center of the circle? Which circle? The big circle, the full original lamina, the center with respect to center of the main circle or the big circle. Then, see, you write this distance left side, this is down, this left side will be, this is 200 by 200, from 100 subtract 97.917. So you make a note there, from 100, see, this distance will be, from 100 subtract 97.917. Sorry, calculator is not on. 100 minus 97.917 is 2.083. 2.083, and from center of circle, the downside you have to come by, from 100 subtract 98.125, that is 1.875. You make a note. Okay, now do one thing, one note. Okay, you write the sketch. See, I told how much? 1.875, and another one is, well, first one I got 2 point, x wise 2.083 left side of center and 1.875 downward of center I told. Okay, make a note, then remove it. Now this question is over. See, now I will remove once again. This all I will remove. Okay. Make a note. Make a note. What all I dictate, what all I dictate, you are right. We considered origin O Abelco. That's all, Abelco. That's all. I won't tell what is Abelco. Google it. Abelco. But if you use brain, or sorry, not that you don't have brain, if you think a little, you can solve very easily by considering origin here. See, the origin here. This I remove. You can take origin here. I will tell advantage for you, but some student will tell, sir, you only told, sir, don't. Yes, don't take. For those who want concept, you take origin here, and take this as x and this as y. Okay. Now, then your origin will coincide with G1. Remember, G is the center of circle. You take origin there. Make a note. You take origin here. Then work is very fast. See, once again, start. E1 now formula is what? A1y x1 minus A2 x2 formula remains same. A1, A2 will remain same. X1, see. G1, centroid is here. From here, x is 0. Y 0. From here, G1 is there only. And even y also 0. See. From origin to centroid G1, there is no x distance, no y distance, 0. But these two you should be careful. X2, Y2, see here. X2, here centroid. 30 plus 40 by 2, that's all. 30 plus 40 by 2 is 50. And Y2, 25 plus half of, it is 25 plus half of 40. 45. Okay, now calculate x bar, y bar. See, once again I will tell you, x bar equal to a1 x1 minus a2 x2 divided by area. Y bar equal to a1 y1 minus a2 y2 divided by area. X bar will come minus 2.083 millimeter, and y bar will come minus 1.857 millimeter. I got guaranteed. I won't calculate. 875. Oh, 875. Okay. 875 millimeter. Okay. You get this answer. Okay. Now see what to do. Now make a note. What is the meaning of this negative sign? We took x bar, see, we took x from origin to right side. X. So x bar also comes to right side, but unfortunately negative came. So your x bar is not right side, it is to left side. See. So therefore, if you take this is your origin system, this is your x, this is your y, your x bar is to left side. How much by? 2.087. See, somewhere here. How much it is? Left side you have to come. So right here, from the origin here, space is not there. It is to left side by, now no negative. See, we took right side, negative came. When you take negative, now left side, no negative. 2.083. And y bar, we considered upper side, negative came, so little lower side. Where right here, see, from center of circle here, that origin point, it is downside of 1.875. Yes, the same answer we got earlier. Now do one thing. If somebody wants this distance, and this is centroid G, I told centroid will not depend upon your origin or division of parts. If you want from here, you write here. This is 100. See, from here to center is 100. From 100, subtract 2.083, you will get the same answer we got last time. And if you want from bottom edge here, if you want this distance, from 100, 200 by 200, subtract 1.875, you will get what answer you got last time. So This question is over. Now, question 73 over. 74, see what I am doing. 74, what I am doing. See, same question. Circle remote here. See, this is a remote circle. That's the reason. Same question. See, how much I took there? This is 25. See, this is 25. Same answer. This is 30. 30. Same question. I am removing circle this side. See, now more concept will come. Okay. I will change that value. Start then. 74. Okay. Now, I already told you, same numericals are same because I can save the time. Same. Cut out here. Same thing. All the statement will remain same. And then main part is 200. Cut out is diameter 40. See, 30 this side, 25 this side. Okay, now, actually, whatever x bar you got last time from this side will come from that side. And whatever y bar you got last time from bottom, you will get from top. Or whatever you got from top last time, you will get from bottom. This type bottom. Then don't bother it. Okay, start. Figure number 1, 2. This all same statement. See, area will remain same. G1 is here. 200 by 2. 100. G2. See, x is this side. Be careful. So no negative. It is. See, from here to here is how much? 100. Last time, see, it was here. So what I wrote? 100 plus something. Now, 100 minus 30 minus 40 by 2 is 50. G2. See, last time it was 100 plus something. Now it is 100 minus 25 minus 40 by 2. 40, 55. You will get x bar, y bar. Calculate. Therefore, centroid will be, see now, x bar and y bar both came more than 100. Means what? From here, it will go slightly that side of G1 from center of circle. Here also will go above. Why? Correct, because this side more area is there. We are removing area on the left. Last time you removed area on that side. So centroid shifted diagonally opposite. Now you remove area this side, centroid will shift diagonally opposite. So see here, x bar. This is center of circle. See, center of circle here. You can do one thing. Okay, you do one thing. Center of circle. See, you can make a note here. This is center of circle. Just a note. Center of circle. See, to understand. Last time I forgot. So, x bar we got 102.083 means from here to center is 100, little more. And y bar you got 101, slightly above. You write all these. Then make a note. Suppose somebody wants centroid location from center. Then this distance is 102.083 minus 100 is 2.083, and if you want this distance downside is 101.875 minus 100 is 1.875. Make a note. Okay, then remove it. Over. Now, see, this full over now. Full I will remove. See, remember now, from center, centroid is, from where? From center, centroid is what? Left side, sorry, to right side, and so this is actually up. No. This is actually above, not below. Above by 1.875. Oh, what is this one? Okay. So we got centroid with respect to center, how much? Right side and upward by these two numbers. Numbers are there. So I will write here, we got right side here and we got upwards here. Okay, done. Now, everything over, make a note. Once again, same note you make once again. That instead of taking reference axis O, that is Abelco, suppose you take origin O through center of the circle O. Then see here. This is X and this is Y. Y. I don't know. Actually, this is more and more concept now. If you take this way, see what happens then. A1, see, center of circle C, origin O and G1 all will coincide. These two will become 0, 0. 0, 0. And this will be very, very careful now. See, now what about this distance? See, G2 is here. Our X is to right side. Make a note, our X is to right side. But G2 is to left side by how much? 30 plus 40 by 2. See, it is 30 plus 40 by 2 is what? From origin O to G2 in the X direction. But this from origin to G2 is to left side. But our X is right side. Therefore, without forgetting, put to minus sign here. And that's why I told concept case. G1 is here. See, sorry, G2 is here. From OX line, see, our Y is upward positive. But your G2 is below by how much? 25 plus 30 by 2. 25 plus 30 by 2. But that is, sorry, more space required. Okay. 25 plus 30 by 2 is a numerical value. That is how this distance. Our Y is above, so you are right, minus sign here. Your X bar will come, Y bar will come. I'll calculate now. Where is the calculator? Actually, I'll use calculator, not this way, this way. Plus 2.083. It will come plus only, not minus now. See, last time you got negative sign. This time negative will not come. I will tell you why it will not come. 1 minute. It's a color problem. Okay. Plus 2.083, correct. Plus 2.083 millimeter. And Y bar will come plus 1.875 millimeter. Over. Now, make a note. How plus comes? See, A1, Y1 minus Y minus, cut out minus A2 into minus Y. See, A1 X1 minus Y minus because cut out. And A2 into minus of this number, Y minus, that minus is not for cut out. That minus is for left side X. Okay. You got X bar, Y bar, correct. So therefore, now presentation, see now. Lastly, presentation. Centroid G will be, remove this one. Okay, see here. Your origin is here. Center is origin. From here, you are taking X. This is your X and this is your Y. Y. Now, see, this is your negative X, negative Y. Okay, now, X bar, we took X to right side. Answer came positive, so correct. It is, see here, from the reference axis here, small distance. See, this way, right side of 2.083 and from YY axis here, see, from here, from the reference axis here, Y bar, it is upward of this X bar, I write X bar equal to, okay, this is Y bar equal to 1.875 millimeter. That is same as the answer we got just now. Over. This question is over, 74 over. Now, sufficient, but one interesting question I solved. That question was asked in GATE. In one GATE paper, that question was asked. Therefore, I solved the question GATE. How it was asked is right here now. See, they show a circle here. Then one more circle they removed exactly here, tangentially. They asked you in the question paper, from centroid, CG will shift to left side or CG will shift by, 4 options are given. Okay, I'll solve it. Not much work. 1 minute work actually. So last question. Anyway, 74. 75 is what? 3/4 of century. Okay, 75 is a good number. Golden jubilee, silver jubilee, I think diamond jubilee, diamond jubilee. So 75 is the last question. Same. Locate centroid if a circular hole is, okay, locate centroid if a circular hole of, no, I will do one thing. I will just sketch only for you. No words, because it is very easy actually for me. I will prepare the question. Now, last part, question 75. See, question is, you can make out with the question, words not required. Locate CG, locate centroid. Locate centroid. For the given lamina. Very crystal clear, see. This is center of circle. This is 100. Means diameter is 200. Dia equal to 200. From there, a circle is cut out correctly from here to here. See, it is tangential here. See, in the class, exact circle I cannot draw. Difficult. For that you require what? Electronic board. Here it's not possible. So, somewhat reasonably I have done it. So, therefore, for this one, we want a dia. Dia equal to, see, if this 100, this is 100 only. Diameter equal to 100. Why? Because you can make out, see, 100, 100. Now, class, what all I told earlier, all stands good. Then formula same. Take origin, see, Abelco, take origin here. A1, pi by 4 of 200 square, 31415.927. A2, danger, pi by 4 of 100 square. A1 minus A2 will give total area. Someone asked me long back, sir, you can do one thing, sir. That diameter is 100, 200, this diameter is 100. So, area is half of the full area. What nonsense is that? It is not half of the full, it is 1/4 of the full. See, I don't want to tell actually. Some person told, see, 20 mm diameter bar. 4 bars of 20 mm diameter came in RCC. Some brilliant person with a brilliant idea. He told, sometime practically what happens is, when you put high diameter, people get upset. They will tell, no, thick bar you are providing, wasting steel like that. So he told, do one thing. He told his assistant, don't give 4 of 20 mm. People will start bargaining, 20 mm big diameter, waste of steel. So do one thing, you tell him 4 of, no, you provide 8 of 10 mm bar. See, 20 mm bar, he told 4 of 20 mm replaced by 8 of 10 mm. He thought 4 of 20 rupees note or $20 note replaced by 8 of $10 note. Rupee it will work out, but here it won't work out. 4 of 20 mm bar, if you are replaced by 10 mm bar, you require not 8, you require 16 bars. Why? That is 20 square, 400. This is 10 square. So area of 20 mm bar is 4 times of the area of the 10 mm bar. So that much common sense should be there. Therefore, always better. Don't go for imagination. Suddenly, oh, that full area is diameter 200, 100. So whatever area is there, half the area here. No. Okay. Here over. Now, x. See, G1 is here. X1 is x this way, 100. 200 by 2. G2, 100 plus half of 100, 150. Oh, one thing forgotten. Oh, one thing forgotten here. As you write the sketch here, see, you write the sketch first. Then, before you start, see, before you write these expressions, before writing the expression, you write here. See, correctly observe here. This is axis of symmetry. Axis of symmetry. There is symmetry here. Therefore, this distance and this distance will be, if 100 means both are 100, 100. Therefore, you do not require, y bar is not required, we require only x bar. So, only x bar required. So, x from OY over x bar will come 83.333. A1, A1 x1 minus A2 x2 by total area. So, from here to here is 100. 83 point something means, see, somewhere here. This is your x bar, see. Very simple. If you shift this side, x bar, you got 83.333. Okay, then this is your axis of symmetry passes to centroid of both. Therefore, this is the centroid G. If you want from here, directly you can tell 100. From there also 100. 100. Both are 100, 100. But if you want here, it will be how much? 116.667. This is the answer. Okay. This question is over now. Now do one thing. Make a note. Note. This question also, suppose we change the origin. Suppose you take origin exactly through, see, G1, this is center of the circle, you make that itself origin. Then this is Y, this is your X. Okay. Then your X bar, this all will remain same. A1, A2 will remain same. X1 equal to 0. X2 equal to the right side 100 by 2 equal to 50 mm. Substitute, this I'll remove now. 1 minute now. Before you go there, if somebody wants what is this distance from center, how much? If somebody wants this distance, it is 100 minus 83.333, 16.667. You write there in the previous question, previous presentation. Now, x bar will come, see, A1 x1 minus A2 x2 divided by area will come minus, it will come minus, I am sure, minus 16.667. Okay. Then your presentation is how? Then your presentation is, see, OXN not here, right here. See, your origin is here. Here origin. This is your Y. You should be careful. This is Y, upward positive, X right side, but actually Y is not required, X right side. See, actually this way you don't have to locate because exactly center, symmetry is there, 100, 100. 100, 100. But this way, from origin here, see, this is your origin O. Origin O, which is also center of circle. X bar, your X, you took right side. Negative sign came. So, it is not right side, it is left side. From center of circle, it is left side by 16.667. That is from here, 100 minus 16.667, same as last time answer. This is centroid G. Okay, now do one thing. Just one exercise for you. I will give a small exercise for you. Instead of removing this way, see, anything removing? Okay, okay. If something is not removed, do one thing. See, take a question, same way. This way, diameter 100 only, dia 100. You remove circle here. This way remove circle. Okay, again, diameter is 100. I will tell you what happens now. If you take origin here now, see, you write this question. There is axis of symmetry here. You don't have to locate. Now, YY is symmetry axis. So you require only Y bar. You require only Y bar. From here, your Y bar will come same as last time. How much it will come? Little lesser. It will come 83.333 will come from here. Correct? Yes, Y bar will come 83.333 this way. See, this is the axis, centroid. But if you take center origin, from here, your Y bar will come minus 16.667. Work out one question. This question, X bar required, Y bar not required. This question, X bar not required, Y bar required. Work out this question. That's all. I decided to stop the centroid now. So many 75 questions. See, but before 75, earlier so many master questions were solved. Not solved, solved. Okay. Now, in case I suddenly feel, oh, one question is pending, maybe see, this way, and this way. Somewhere if I see, suppose such questions, actually you can solve now. If I feel any extra questions are required, I will do it at the time of moment of inertia, because moment of inertia, once again you get it. Okay, I will conclude the class now. Next class is the most powerful in structural engineering, moment of inertia. Remember, I will first explain the principle of moment of inertia, how it is calculated, what is the basic of them, what is the basic concept, and then I will go for some derivations called one parallax theorem, one perpendicular axis theorem. I will define two more terms called radius of gyration and polar moment of inertia. Once I finish that one class I will give very thorough explanation about the real meaning of moment of inertia. See, I will give an example for you. Suppose there is a beam, just for information. See, you should start learning now. Okay, some beam, rectangular shape. Okay. No, this is not rectangular, somewhat rectangular. Okay, I will use this calculator only. I use as a beam bending this way. Moment of inertia is this into this cube by 12. If I turn the beam here, it will be this width into this thickness cube by 12. In my class, I always used to tell, when you look at the beam, I can see moment of inertia. Some will tell, sir, how visible, sir? Sir, area you can see, beam length you can see, width you can see, depth you can see. How you can see centroid, somehow you can see. Imagine, but moment of inertia, how you are seeing? I will tell, inner eyes. Because, like I will tell, happiness. You know what happiness? Yes. You are feeling happy? Yes, sir. Show it to me. How is it? Sir, it can be only felt, sir. It cannot be shown by laughing. Laughing not allowed. Laughing not allowed. Okay, seriously. This is why you should stand. No laughing, nothing. Show happiness. Or show pain. Sir, pain. Don't show nothing. By words, tell me. Not possible. Somebody else, if he is not looking at you from backside, can you see you are in pain? Maybe you may do this way. Happiness, sorrow, dull mood, good mood, anger, this all you cannot see, but you can feel. Same way, when you look at a beam, I can see moment of inertia. I can crystal clear see there. See, there's a beam running there. I can see the moment of inertia of the cross section. That because of the involvement, that all feeling, I will tell you in one class. Not first class, because first class I should understand what is moment of inertia. Then I will announce a ultra special class for the concept. Okay, we'll meet in the next class with moment of inertia. Thank you.